The world needs carbon-free, clean energy. And I want my children, and eventually grandchildren, I want them to have a healthy planet to live on. And fusion is so exciting. I don't want it to be always 50 years away, And does it really have to be 50 years away?
Fusion is the reaction that powers the sun and the stars, and we want to use this energy source here on Earth. But how can we harness the energy of the sun, and how soon? In a fusion reaction, small particles join together to make larger ones and release energy. But without the huge gravitational force of the sun, on Earth we need to trap our fuels in machines called tokamaks. It's a Russian acronym, Toroidal Chamber Magnetic Coils, so it's a ring donut-shaped trap for fusion fuels. Now at Tokamak Energy, we have a new approach for developing fusion faster.
Energy is one of the main problems facing the world, and so we need to try and solve it.
Fusion is completely clean.
1,000 years or so of good electricity supply that doesn't mess up the atmosphere.
This is like the holy grail of energy.
To achieve fusion, charged particles need to overcome the repulsive force between them. This means they need to be moving incredibly fast, so they collide hard, which means our fuel must be really hot, over 100 million degrees.
This is not science fiction. We have actually achieved the temperatures which exceed well the interior of stars.
At such high temperatures, atoms break apart and become a charged gas called plasma, the fourth state of matter. Charged particles are affected by magnetic fields. They spin around field lines. So we can use magnetic bottles to trap our fusion fuels.
The essential feature of a tokamak is a strong toroidal field around the torus, and this is produced by passing current in these coils. The plasma shape is controlled by the field in these poloidal coils.
The JET tokamak here in Oxfordshire is the biggest in the world at the moment, and the ITER device in southern France is now being built. The Tokamak Energy team can learn a lot from these big fusion devices, but we want to do fusion smaller and faster.
Tokamak Energy wants to accelerate the development of fusion power, and we'll do this by combining two emerging technologies: efficient spherical tokamaks and high-temperature superconductors. A spherical tokamak is a tokamak that has been squashed up, so it makes more efficient use of the magnetic field at the centre. High-temperature superconductors can reach higher magnetic fields at more attainable temperatures.
Tokamaks always dreamed to demonstrate possibility to run continuously. There are no magnetic fusion devices that run more than a few hours, and this will be the first one.
We've already built a small tokamak, ST25, and also the world's first tokamak using entirely high-temperature superconducting magnets. Theoretical work has been published that shows that tokamaks don't need to be as big as scientists originally thought.
You need a high temperature to get fusion, so for a fusion power plant you really need to get those high magnetic fields. One of the exciting things for me is having a small device allows you to develop a lot faster, so you can develop more of the latest technologies quicker. I think it's extremely exciting technology. We need the high magnetic fields, and that's the way you're going to get them.
One of the great attractions of the small fusion reactors is if you want to generate a few gigawatts, essentially you have a farm of these miniature reactors. So you can see how each individual one can be manufactured much more economically than a giant one.
By starting small and building up quickly, Tokamak Energy wants to accelerate the development of fusion power on Earth.
We are aiming to build the first fusion device to achieve an energy gain.
Fusion is about to get a lot more exciting.